Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video we see how to print a linked list in C programming and how actually this code works. So before we begin, it is a request to please subscribe to my channel, and if any of my previous videos or if this video has helped you out, so please do subscribe to my channel. So in the previous video we learned in depth on what is a linked list in C programming, okay? And we went through the basics. We saw what are nodes, how do you create a node, how do we have a struct node. Linked list is basically struct node objects in C programming linked together using the pointer inside the struct node, okay? Alright, and then we saw how it is actually stored in the memory behind the scenes, and we also saw a little about what typedef is and how we are going to use in my videos, how I'm going to use in my videos this typedef to create an alias for this struct node so that I can use one single word node, okay, to create a node. Okay, and by the end of the previous video we wrote this method to print the linked list. Okay, so if I compile and run this code, okay, this is my linked list. Let me just comment all this output. This was just to demonstrate that the nodes are linked together. Compile. Okay, so this is my linked list, 238 197 null. Okay, 238 197 null. The values in the nodes as we saw. Okay, now how is this code working? Because code to print the linked list remains the same. However, we don't create the linked list something like this. We don't create node objects directly by doing n1 and 20 till 100. We don't do that and then we link like this. No, we use dynamic memory allocation. We use malloc to create nodes as we need on the go and free the memory as we remove nodes. Okay, but this code remains the same. So a print function, you will always get the head of the linked list, okay, which is the first node in the linked list. You say current equal to head. When you do this, you are copying the value in this variable in the right hand side into the left hand side variable. Okay, so head is a pointer that stores a memory address. That memory address is copied into current. Okay, head is a pointer to this node. So if I get a memory, okay, to store, okay, a node pointer, the type of this is node pointer, okay, storing the value it stores is the address where this n1 is stored, because head is the address of n1, first node. Head is a pointer to the first node. Okay, so current will also point to the first node. Okay, then you say while current is not equal to null, so I'll take this condition here. Okay, current is not equal to null. Okay, so current is a pointer, either will store an address or will store null. It is currently pointing to this object not equal to null, true. So you go inside this function. Okay, if this is your output, okay, you print f %d with an arrow, and the value that you print in place of %d is current.x. So current is pointing to this node, the x value here is 2, so you print 2 and an arrow. Okay, 2 followed by an arrow, and then you do current equal to current.next. When you do this again, the value in current.next is copied to current. Current.next holds the address of this node. Okay, current.next is a pointer to this node, so now current also is a pointer to this node. Okay, you go back to check for while loop condition. Current is not equal to null, current is pointing here true. You print %d with this current.x. Current.x is 33 now, current is pointing here, so you print 33 and this. Current not equal to null is true when current.x was 2 and 33. Okay, then you do current equal to current.next. Current.next is a pointer to this node, so this current also points to this node. Okay, you say current not equal to null, this is the node, not equal to null is true. Okay, you print %d with arrow current.x. Current.x is 8, so you print 8 and an arrow, and then you do current equal to current.next. Okay, current.next is a pointer storing the address of this location, so current also is now a pointer to this location, which is n4. Okay, the fourth node. You go back to check for while loop condition. Current not equal to null is true. Okay, current.x in this case is 100, so you print 100 followed by an arrow. Okay, and you do current.next. Current.next is a pointer to this, so current is a pointer to this now. Okay, you go back to check for while loop condition. Current not equal to null is true. Current.x is now this value, say it is 97. Okay, you print 97 with an arrow. Okay, you say current equal to current.next. Current.next is now null, so current is now null. The value at this variable which was storing address of head, then this, then this, then this, then this is now null. Okay, current is null, current not equal to null is now false. So the loop breaks. Okay, so you see how the current pointer started from head, iterated the entire list, printed each value in each of these current nodes, okay, and then went null. Okay, and this is a very standard way to iterate a linked list in C programming and any programming. Okay, then you print null and change a line, null and change a line, so you get this output that we are getting here. Okay, so when you go through textbooks, posts or articles about C programming and linked list, you won't have something like this. This memory diagram is something that you won't usually find. You will find something like this circle and arrow thing. So if I create this and try to explain you using the current pointer with this, okay, because I'm going to use this approach very frequently in the upcoming videos. So my head is here. Okay, my current starts at head, because when I say current equal to head, my current also points to the same node where my head is pointing to. Okay, I say current not equal to null, so I get my conditions again. Okay, and I current dot x. Okay, current dot not equal to null is true, current is pointing to this, so this is 2, current dot x is 2. Okay, so you print 2. Okay, all right, then you say current dot next is this, so current now points to this. Okay, current not equal to null, current is pointing to this node object not equal to null 2, current dot x is 33, you print 33. Okay, and then you move on to the next, so you say current is now here. Okay, current is not equal to null is true again, current is pointing to the struct object containing the value 8, current dot x is 8, you print 8, which we saw, and then you move on to the next node, current equal to current dot next. Okay, so this arrow basically denotes the next. Okay, that is how we usually denote. You print the value 100 as you saw, and then you move on to the next node, so current comes here. Okay, again current dot not equal to null is true, current dot x is 97, which we print here. Okay, current goes to current dot next, so now current becomes null, which the condition becomes false, and we have this output to 33, 8, 197 null. Okay, this is how printing works. Okay, and this is a very standard way that we iterate a linked list, that we start with the current pointer starting at head, we keep going to current dot next while current is not equal to null. Okay, if you want to go till the last node so that your current stops here, you say current dot next is not equal to null, so that the current stops here at the last node. Okay, we'll see that in the upcoming videos. Okay, so this was the C program code to understand how printing a linked list works. All right, so we have just covered the basics of linked list. We haven't really created nodes using dynamic memory allocation and linking them together. We do that in the next video where we insert front, middle and end. Okay, and then you start removing nodes and so on. Okay, so I hope this video was helpful and you like this video. So if there is any doubt, this part you don't understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there's a question you want to solve or if the concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.